In this video, I am going to show you how to express one vector as a scalar multiple of another. So let's take a look. You may be going through a calculus book and you see an exercise that says the following. You're given a vector length. Okay, so you're told that the magnitude of some vector is something like 3, and that this vector here is parallel to another vector, maybe represented using the letter U, whose components are 1 negative and 1 positive, like this. And now the question is, find a vector whose length is 3 and that is parallel to this one here. So how do we approach this? What we have to know to do is the following. Draw a coordinate system. So your y-axis and x-axis. Okay, call this x. Call this y. And mark that point. So you've got your negative 1, comma 1. So here, for the sake of simplicity, I will take 3 spaces to be a 1. And for the sake of visibility, there we are. Okay. So negative 1 means this, and then positive 1. So that means we are at this point here. Okay, so this is our vector u. Okay, so what we want to do is get another vector that is in the same direction as this one, but whose length is 3. So we will use cosine and sine functions to accomplish this. Let's mark the angle. So that's our angle theta here, okay? Now the question is, what is the angle that this vector makes with the positive x-axis? And the way to visualize that is the following. There's your angle. And let's take a look at the components of this vector here. Those components are the following. I'm going to sketch them in red. Okay, this one here is the x component, right? The red one here. A little arrow. And another arrow, this one here, that represents the y component of the vector. Okay, so this vector consists of an x and a y, which means, of course, we have a triangle. And once you have a triangle, you can use the inverse sine function, inverse tangent, the inverse functions. So in our case, let's label the point negative 1, comma 1, like this. This is our angle theta. And let's find it. What we have is, and here it will be convenient to use the inverse tangent function. Okay? So theta will be equal to the tan inverse of 1 over negative 1. And of course, if you refer to the unit circle, you find that this is equal to 3 pi over 4. Okay, so the angle whose tangent is negative 1 is 3 pi over 4. Now that we have this in place, we make another observation, which is this one. Any vector can be expressed in the following format. A vector v can be expressed as its magnitude multiplying the cosine of an angle, and that's your I, plus the sine of an angle, and that's your j, like this. Okay? Any vector can be expressed as this. The length of the vector multiplying this vector here. The vector that you see here, the cosine of the angle and sine of the angle, that is a unit vector. Its length is always 1. So we can take it and multiply it by v without distorting things. Okay? So in other words, what it's saying is this. Okay, for the sake of simplicity, say you have your number 4. And if you multiply 4 by 1, what do you get back? You get 4 back, right? And if you have 5 and you multiply by 1, you still get 5 back. If you get 6 and you multiply by 1, you still get 6 back. You see? So the same principle applies here. You're given the magnitude of a vector, such as 3. The length of this quantity for any angle is 1. So that means when you multiply this by this, you really get back just the length of the vector and not some other number. That's what I mean by it ensures that things are not distorted. What if the length of this quantity were 2 for any angle? Then you would have 3 times 2, which is 6, you see? And that would be different. So this is what you do. 3, and then you multiply. The cosine of 3 pi over 4I plus the sine of 3 pi over 4j. Now cosine of 3 pi over 4 is 3 times negative root of 2 over 2I plus the root of 2 over 2j. So you end up with negative 3 root 2 over 2I plus 3 times the root of 2 over 2j. So what is this telling us? It's telling us the following. There's a vector whose length is 3 that is parallel to this one, and the components of this vector are as given here, like this, okay? So what you might want to do is take this now and draw this. It roughly would look like something like this, okay? That's what we've done. We've taken our vector u, we've used concepts from trigonometry in the unit circle, the cosine function and sine function. This vector here, cosine theta, sine theta, this quantity here is a unit vector for any angle, so you can multiply by a constant, and the constant value doesn't change. We replace the angle with this found from the inverse tangent function. Then we apply the values. So cosine of 3 pi over 4 is negative root of 2 over 2, positive root of 2 over 2 for the j component. Then you distribute the 3 over, and you end up with this as the final form of the vector. There you go. Thank you for watching.